All right, so let's look at the situation of the displacement of a drag racer. So a drag racer, starting from rest, travels 6 meters in 1 second. Supposing the car continues this acceleration for additional 4 seconds, how far from the starting line would the car be? All right, so it looks like here we're solving for distance again. I have a note here. Using kinematic equations takes a long time for this problem. Use the quadratic relationship to reason out our answer. All right, so reason why I say this. So if we're solving for position, so our position, that's our initial position plus our initial velocity times time plus 1/2 times our acceleration multiplied by time squared. Right, in this situation here, our initial position, it would be convenient to call that 0. Right, so we say we start from our 0 position and go some distance away. And I forgot to underline this, starting from rest. So that means our initial velocity is 0. So we're left with that our final, so our position is going to be equal to 1/2 our acceleration multiplied by time squared. All right, so in reality, I could just use the kinematic equation here, but I'm going to show you how to kind of reason through this by using proportionalities. Right, so we see here that position is going to be proportional to time squared, right? So another way to write a proportionality is that our position is going to be equal to some constant multiplied by time squared. And we're given two things here so that we can simply solve, because we know how far we go in 1 second. All right, so let's kind of use that information to solve for C. We know that we go 6 meters is going to be equal to our constant times time squared. So we see here, so 1 squared just gives us 1 second squared. So we have 6 meters divided by 1 second squared. And yes, I apologize for not rearranging first. That is a big faux pas on my end. So our constant is going to be 6 meters over a second squared. Right, so that gives us our constant. So we can write that x is going to be equal to 6 meters over a second squared times time squared. All right, so if we're accelerating for an additional 4 seconds, right, we have to be careful because it's an additional 4 seconds. So it's 4 seconds plus that 1 second we already traveled to find the position we're looking for. So looking for the time at 5 seconds. So our final position is going to be our 6 meters over second squared multiplied by 5 seconds, that whole quantity squared. So 6 times 25, that gives us a value of 150 meters. Let's actually now cover the next question as well. All right, so another kind of don't use the kinematic equations problems. So we have a cyclist at rest at a traffic light. When the light turns green, he begins to accelerate at 1.2 meters per second squared. How many seconds after the light turns green does he reach his cruising speed of 6 meters per second, right? So let's see, a cyclist begins at rest. He begins to accelerate at 1.2 meters per second squared. How many seconds? That's what we're solving for. Does he reach his cruising speed of 6 meters per second? All right, I say don't use the kinematic equations. Think about what acceleration literally means. Well, acceleration is our change in velocity over time, right? So here we're dealing with units of seconds, right? So our acceleration here says that for every 1 second, we're going to increase our speed by 1.2 meters per second, right? So if I made a table of our time and our velocity, so let's see. At 0 seconds, we're moving at 0 meters per second. So let's have 1 second elapse. Right? Well, my velocity then is going to be 1.2 meters per second. At time equals 2, so another second has elapsed, we'll be at 2.4. All right, I'm going to drop the units, we'll have it carry it through. So at 3 seconds, we'll be at 3.6. At 4 seconds, we'll be at 4.8. And at 5 seconds, we'll be at 6.0, which is what I'm looking for. All right, so it takes us 5 seconds to travel to reach a speed of 6 meters per second. right? So here I did not even have to use a kinematic equation to get to our answer, though we could have. It would have gotten the same answer. But this is just another approach you can take to some problems, not all problems, right? Here, because they told us what our final speed was, we're able to do this logic. And sometimes that number may be too big for us to do this in a reasonable amount of time.